Here we have ticket number 12569, and it's a Nintendo Switch that has Wi-Fi issues. That shiny chip in the middle that you can see is the Wi-Fi and Bluetooth IC. And what's really interesting is that the Bluetooth side of this device works fine. So the controllers, no problems at all. According to the job notes, we're greeted with an error code of 2110-1118. And apparently the error code doesn't give that much information apart from it's a wireless problem. My colleague has also said that there's a little bit of damage on the actual chip itself, so we're going to have a look at that underneath the scope. We have confirmed with the customer how much the job is going to cost and ordered the Wi-Fi IC. Let's now go over to the scope and take a look at the damage on the chip. Now I'm going to try my best here to get the most suitable lighting because this chip is shiny, so it's extremely tough. Oh, you can see a marking up there and a little crack on the corner. Can you see that? If I'm able to use my tweezers, you can see just a little crack here on the corner of the IC, and I don't know, oh look, yeah, I think that's just fallen off a little bit more, but that's also a crack here. Perfect. Okay, so we can physically see damage to this IC, which would indicate that at some point, I'm going to guess it's got relatively hot. We can see pin 1 is located here just about, but what's nice is that we also have a pin 1 indicator up here, but that's definitely going to cause issues. I will just measure this cap here, considering we've got the damage on the IC here. I think it'll read normal, but we'll double check. This is in continuity mode. I'm just going to measure that cap just to see. Yeah, we don't have any shorts. Okay. I think if we had a short on the actual chip itself, it would knock out the Bluetooth side of things as well. So I think it is just a case of a specific area of this chip that controls the Wi-Fi is damaged. That's not very ideal when you're using a Nintendo Switch, a portable device most of the time. So we're going to come straight in with some heat and remove this IC. It's very, very difficult, this job, purely because of the fact we have so much stuff around it in such a small space. I'm going to have to get my tweezers and slowly wiggle this off when I've applied enough heat. A little bit of flux to help us out as well. Okay, let's get this show on the road and hopefully we can repair it for the customer. Temps, I'm feeling around about 450 degrees Celsius because it's a Nintendo Switch board. They're not necessarily too thick. Airflow speed of about 70. Going to warm everything up first before I go ahead and put some flux on. I just really hope that I don't slip and knock this. Okay, the area is a little bit warmer now, so I'm just going to add a tiny bit of flux, not too much. Just around the outside. And on the chip itself, I guess. There we go, that's better. Now I'm going to come in with my tweezers. And I'm just going to pick about here. Hot air. And gently lift. Now I'm not using a board holder or anything because what I'm relying on here is the weight of the board to pull and pull the chip. So I can pull the chip, there we go, just like that. Nice, nice clean pull, move that away. Whilst the board is hot, we want to apply a little bit of flux. Come in with our soldering iron and leaded solder and just go over the balls that we have and mix that leaded with unleaded, making our wicking process easier. There we go. I think the easiest way to do this is going to be with a single piece of wick rather than chopping them up into smaller bits. So again, we just come in with the iron, place down on the wick and slowly left to right. Chopping our wick as we go. And if I need to apply more flux, I will, but we're looking okay at the moment. There we go. That looks pretty clean, in my opinion. I'm going to come back in now with the hot air gun, and I'm just going to melt around the area of the flux, and then use a cotton swab to clean the area up. And then we can get a proper visual to see what we're working with. There we go, that area should be warm. Like I said, just come in with a cotton swab. Take that flux. Just see a bit clearer. There we are. If the board is warm enough, you'll be okay. Then what I like to do is just take a little brush, IPA, and get rid of any potential fibres that have been left over from the cotton swab. There we go. Now in terms of how prepped is that, I would go ahead and say nicely prepped. We don't have any solder balls sticking up that would cause issues from what I can see. So we should now be able to just place the other IC on and flow that into place. Now the way I do this is, again, by applying the tiniest bit of flux on the centre of the board, or the centre of the chip, sorry, where you're going to be placing it. And then with a cotton swab, just dragging that around. You can use a finger as well. Now I have the IC, the replacement one. See, it's not an ideal position. I'm not just going to solder it like that. But you can see here, that's pin 1. So we've actually got this around the wrong way at the moment. So we pick the IC up, come to put it back down. There we go. That's better. All right, and now I'm going to try and use my finger, but this IC is very, very small. Usually I just use my finger to kind of feel it out. That's not a bad place, to be honest, but I'll just put my finger on it and just give it a little bit of a wiggle while I was pushing down, giving it a bit of pressure. Come back in with the tweezers, lift up. How's that? Completely out. All right, let's try that again, shall we? Just like that. Tweezers. How's that? Again, a little bit skew with. I think it's a bit too much of a sensitive area to be able to get the feel on putting this one on. So I'm just going to try and line this up as best I can. Exactly the same temps as removing the chip, so 450, 70. And I'm just going to hover it over. And what we should see is the chip dance into place in a second, because there is a little bit of flux. Sorry if you don't have the best view, but I'm also trying to make sure I don't mess it up. I'm going to come in with a tiny bit of flux now. More so than the tiny bit that we had before. Leave it there. And we should see this hop, skip and jump into place now. There we go. See that? See that little bounce? And usually I like to tap the chip and just see it back into place, but I'm not going to do it on this occasion, purely because of how sensitive the area is and how we have so many different components. So I'm just going to wait for that to cool a sec before I come in and clean up. And whilst the board is hot, I'm not using isopropyl alcohol here. I'm just simply using the swab on its own to get any flux that I can. Now I can come in with some isopropyl alcohol, but the board is a little bit cooler, and a brush, just to ensure that we get what we can. This area is going to always have flux in because it's so tough with all the components we have. But in my opinion, that looks like a good job, and all we have to do now is give it a test. I know. I'm pretty much bold now. After installing the Wi-Fi IC, we booted up the Nintendo Switch and we had Wi-Fi. It was amazing. Everything was perfect. Then we went to use the Joy-Cons and the Joy-Cons weren't working, which would then suggest that the Bluetooth wasn't working. We tried to pair the Nintendo Switch up with a speaker as well to find Bluetooth, and it couldn't find anything Bluetooth related. So the Bluetooth is now not working. This chip controls both Bluetooth and Wi-Fi. I gave the chip a reflow to see if that would fix it, but it hasn't. So I've had to order a new one. And it's now a couple of days. I think it might be even like a week later, hence the boldness. So I'm going to replace the chip with the one that we've been sent, and hopefully we get both Wi-Fi and Bluetooth. When I installed the second Wi-Fi IC, I went to test it and I had no power. I had about 300 milliamp draw, and the battery, from what I remember, was 100%. So I knew that it was something to do with the Wi-Fi IC. So I went and just reflowed it quickly just to make sure that there was definitely contact. I still had the exact same issue. I took that Wi-Fi IC off the board and I reballed it using a stencil that I have. My wife actually brought this into work for me. Rather than ordering another chip from the same supplier, I didn't want to risk it, so I thought I'll just reball it. This is the stencil, an Amoe one, and the Wi-Fi IC stencil in particular is here. The reballing process was absolutely fine. I put that same IC back on, so remember this is the second IC. Put it back on and I don't have Bluetooth or I don't have Wi-Fi. So I said the next thing I'm going to try is take a donor board with the exact same model number and try the Wi-Fi IC from this one. So I reballed that. Lo and behold, I put it on the board, I turn it on, I have Wi-Fi and I have Bluetooth. So I have both of them. I don't know if the particular IC that I maybe ordered was incorrect for the board revision. I don't know. It was a HAD board, not a HAC. At least we now have a fully working Nintendo Switch. And most importantly, as always, another happy customer. I hope you like the boldness. Thank you very much for watching, and I will see you in the next one. Peace.